x equals cosine squared x.
Okay.
And then 1 minus cosine squared x equals sine squared x. So I put those over each other. And then I multiplied times sine over cosine because that's what tangent is.
Okay.
And then I crossed out one of the signs from the tangent and the squared on the denominator. And then I did the same thing for the cosine.
Mm-hmm.
And then cosine over sine is cotangent of x.
Okay. Awesome. Very good. Hopefully y'all got that as well. On the second one, I'd like for you to write in the chat. I don't know if you got all the way to the end, and if you didn't get all the way to the end, you can just write in the chat. I didn't get to that, but I want you to write on the second one what you got as your answer. So you can either write A, B, C, D in the chat, or you can write, I'm not sure. I want you to write that private message, not public message, so that other people don't see your answer. So take a minute to do that. Landon, I saw that you said you got the answer B. Could you explain to us what you did there? Did you get that?
Yeah. So I started off by converting tangent square root of x to sine square root of x over cosine square root of x. And then in the parentheses, the secant square root of x converts to 1 over cosine square root of x. And then that's plus 1 over sine square root of x. So then I needed to make the bases the same.
Of which one?
In the parentheses, I needed to make the bases the same. And so then I needed to add, not add, but multiply 1 over cosine square root of x by sine square root of x, and 1 over sine square root of x by cosine square root of x.
Like that?
Yes.
Okay, and let me pause you real quick right there. Is there another method that some of y'all might have used at this step I'd like to hear? Because there's two ways you can do this from. There's always multiple strategies. Did anybody at this step do this a little bit differently? Just to let you know, this it's also okay if you did it that way. I don't want you to think that you're wrong. Can anyone tell us a different way that you did this here? Or maybe y'all did it that way. That's also okay.
Well, I did it like Landon, but I'm looking at it. And if you add cosine squared of x plus sine squared of x at top, it equals 1.
Where are you seeing the adding of the? Oh, okay. Like after we multiply this, you mean?
Yeah.
You're talking about. You're talking about adding the top here?
Yeah.
Well, I think that's what Landon was going to get to, right? Is that what you're going to do next, Landon?
Yeah, that's what I was going to do.
Okay, so I'm saying like even before this whole process right here, did anybody do anything different than adding these two?
Doesn't secant like square root of theta, isn't that a Pythagorean identity?
Secant squared of theta there?
Yes.
Is it?
1 plus tangent square root of theta.
So did you do it using that? Or are you just saying that's something that we could do?
Oh, I'm just saying that that's something we
Okay,
could.
I got you. Yeah, that is an option, yep. And that would steer you maybe in the right direction and would give you the answer eventually when you simplify. It would be one strategy good. So anybody do anything else? Okay. If not, that's okay. If you did it this way, that's totally fine. There's multiple ways. I just wanted you to be able to see you could do it a lot of different ways. You could distribute this into this. That would be another way, and then you would end up with some stuff that you would simplify. Plenty of ways you could do it, okay? All right, then we can keep going with what you were doing there. So you said you added these, right?
Yes, and then that's 1.
Oh, let me just change that to 1 there.
Yeah, so then it's 1 over sine squared of x, cosine squared of x.
Okay.
And then you multiply that by sine squared of x over cosine squared of x.
From here, right?
Yes.
Okay.
And then you could just cross out the sine squared of x on the top left and the bottom right. And then that'll just be 1 over cosine squared of x times cosine squared of x, which is cosine 4, power 4 x, which is equal to b secant to the power 4 x.
Awesome. Very good. And we should have ended up with B. Awesome. Thank you, Landon. Any questions on kind of just the last week? You had a practice that I sent out yesterday, which you have until Friday to do, but it's just more practice on the trig identities. It's something I want you to be familiar with because it's going to come up in calculus, specifically these identities. What we're doing here in a minute, it'll come up slightly, but the most important identities are going to be these identities. So I want to make sure you feel comfortable with that. So hopefully y'all all got B. That was just kind of a warm up. So if there are no questions, we'll go ahead and get started. So today's lesson is we're on notes number 26. You should either be writing it down on a sheet of notebook paper or if you printed out the notes. We're talking about one last identity today, or two identities, sum and difference and double angle identities, okay? So if you have your formula sheet, this is what I just cropped the formula sheet, and kind of this is what part of it looks like. So we're still talking about the trig functions and identities here. So if you look at it, we talked about the reciprocal identities. Those are like the opposite, sine, cosine, secant, all of those. We talked about the Pythagorean identities, which are kind of these three identities and the manipulation of those. Today we're talking about the sum and difference identities and the double angle identities. That's what we're talking about today, those two. And I know you're like, well, those look long. Don't worry, they're not hard. Those are we're going to be talking about today, okay? We already know kind of Pythagorean theorem, that's review, special right triangles, that's review. We already talked about law of sines, law of cosines. We haven't talked about this one here. We haven't talked about this one or this one here, but if we have some time at the end of the content we're learning this 6 weeks, we'll get to those. So just wanted to kind of give you a preview where we're headed, okay? I'm gonna make one slight change to the calendar. I'm not sure if you got to see it yet. I put this on the Google Classroom. So before what we had was this lesson up here, this lesson back here. Basically everything was, conic sections was here on the 8th. And so I'm just gonna make a slight change. I wanna do vectors is kind of a new unit. And so what I wanna do is end the 6 weeks on the unit of vectors. Conic sections is separate. So originally we had conic sections here on the 8th. And so I'd rather do that starting with fresh from a new 6 weeks after you get that 4-day weekend. And also I thought it'd be good to give you a little bit of a break. And so what we'll do today, we'll close out identities. So this is kind of the end of a unit on identities, trig identities. Then we'll start a new unit on vectors starting Wednesday. And I'm going to give you a break on Thursday. So Thursday will be no class. Any objections? Barring none. We will not have we won't have a Zoom session on Thursday. Give you some chance to catch up with whatever you have for your other classes. I was also reading your Google surveys, and if you still haven't figured it out, or if you haven't filled out the survey, please do, because I do read those. And a significant number of y'all were saying that in many of your classes, the workload has actually increased and not stayed the same through changing to online learning. And so I just want to give you some chances to catch up in your other classes. So every now and then I'll throw in a kind of a catch up / free day if there are no objections to that. So we'll do that on Thursday. So that's kind of one just small change to the calendar. The 6 weeks does end on that Thursday. And so just make sure your grades and all of your classes are where you want it to be and that you communicate with your teachers. I know there's a question about bathroom passes. As of now, as you can see, there is no test. What I'm going to end up doing is just the test that you already have in will be your test for the 6 weeks category. I'll just do whatever your average is will be your 6 weeks test average. And the bathroom passes, if you have them, you can use them for previous tests that are already in the grade book. What you can do for that is you could just take a picture of your bathroom pass or your tickets, whatever you want to use, and then rip them up and then take a picture of them ripped up and tell me what you want it to be applied to and send it to me or mine, okay? So any questions about that? calendar or anything like that. So today we're doing double angle, sum and difference. We'll start a new unit on vectors. Okay, if there are no questions. I sent a Google Classroom, this is just announcements. I sent a Google Classroom kind of picture about something called iExcel. I'm not sure if any of y'all have used that before, but it is an online software. This kind of has, here's your username. It created accounts from Google Classroom for you. This is your username, and this is y'all's password. You can change that when you get into it. So I sent that so you can kind of see your individual username and password. Some of the practices we're going to do on iExcel, not for today, but for probably next lesson. It's just an app you can download. You can just go to the website, and it just has an infinite number of practice problems. And so sometimes we'll use that for practice. So just be on the lookout for that. Okay. All right. So thought I'd start with a quote, given that we want to continue to fulfill our 4 goals, and also just to kind of encourage you. Something I was thinking about for myself. Can someone read this for us, please? I want to hear from y'all because I can't see y'all. Claudia, could you read this?
Perseverance is the hard work you do after you get tired of doing the hard work you already did.
Awesome, thank you. Just in thinking about this and thinking about the 3rd goal, never give up, and as we kind of push through and figure out online learning, and many of y'all may be tired through the home responsibilities that you have, just thinking about life and school and in general, things as a marathon, and being able to persevere is when you're tired because you've been working hard, the ability to still continue to persevere through the marathon of life and through the marathon of school, and just continuing to remember that and not to give up, right? That's just constantly something that we have to decide and to choose to do every day, right? So just a reminder to myself. I tell myself that too, because I woke up on the wrong side of the bed this morning and I was tired and I wasn't feeling good, but I have to persevere and push through to be a good father, to be a good husband, to be a good teacher. And so we just want to continue to remember that, okay? We'll say our 4 goals. We will learn math, build character, never give up, and ask why. Awesome. So let's go ahead and get ready to learn. So we're going to start with the sum and difference identities, okay? This is on the formula sheet, like I said, so you don't have to memorize it. So you can see on here, we see this right here is an alpha there, okay? This right here is beta. So we can say A and B, alpha, beta, okay? So these are showing you if you have cosine of some angle plus another angle. This is an equal sign right here. I don't know why it looks like a minus. These are equal signs. It equals that, okay? So how are we going to use that? Oh. Okay. So this actually came up in last, kind of when we were going over the test. There was one of the problems where we got to, and it was like, I think Claudia asked a question about the problem, and then we ended up saying we can only put this in a calculator because it wasn't on the unit circle. So now we can find what some of these equal even when they're not on the unit circle. So let's say, for example, sine of 15, and we want to see what is sine of 15 equal to. That is not on the unit circle, right? Because unit circle is 30, 45, 60, so on and so forth. So I'm going to go ahead and put it into the calculator so we can see sine of 15. By the way, I downloaded, I sent I think to the group me that if you have an iPad, you can download the TI Inspire, which is what I have here. Or I also sent a link out for if you have you can download the teacher software, and I sent that from Septemvi. So make sure you're getting access to the calculator somehow, some way. But so this is equal to 0.25. Okay, so sine of 15 is 0.25. And so what if we wanted to express that as a radical? How would we do that if we wanted to find that without a calculator? So what we're looking at today, okay? So that is where we can use the sum and difference identities, okay? So we have sine, okay? So I'm gonna split this into 2. These are cosine, sum and difference identities. These are sine, sum and difference identities, okay? And again, these are equal sign. I don't know why it didn't really copy well. Okay, so let's say we want to find what sine of 15 is equal to. Basically, what we can do is we can express sine of 15, instead of sine of 15 degrees, we can express it as sine of some angle that we know plus some other angle that we know that equals 15. Or we can express it as some sine of some angle that we know minus another angle that we know equals 15. So what do I mean by that? What is some, if we think about the unit circle, right? Give me some of the, let's do, let's hear from Natalia. Give me the angles starting from 0 that are on the traditional 16-point unit circle. Not all of them, but just kind of up to maybe 180.
0, 30,
I need to shoot something.
60,
Where's my gun?
90.
What's am?
Hello?
So
Hello?
0, 30, 60, 90,
Wait, we missed one.
45, sorry. 0, 30, 45, 60, 90, 210, 120,
Mhm.
135, 150, and 180.
Okay. You good, by the way?
It's
Okay.
my brother in the background.
Okay, is he playing a video game or something?
Yeah.
Okay. All right. I'm glad that you're okay. I just, it's totally fine. You hear Zane over here all the time. I heard like I need to shoot somebody. I guess he was playing a video game, so I was just a little bit concerned. Awesome. No worries. Cool. So that's kind of some of the values that we have there. Thank you, Natalia. So what we're going to look at is, are there any of these over here that we can add that would equal 15? There wouldn't be any, right? So are there any of these that we can subtract that would equal 15? $45 and $30, right? Yes. So what we can do is we can express this as sine of 45 minus 30. Okay. Sine of 45 minus 30. Because we know what sine of 45 is and we know what sine of 30 is. So the difference identity there allows us to kind of separate it. Okay. Then that equals this. So we can rewrite that as sine of alpha. Alpha in this case is the 45, right? And then cosine of beta. Beta in this case is 30. And then minus cosine of alpha, which in this case is 45. And sine of beta, which in this case is 30, right? Any questions thus far? You can send a message in the chat if you have any. I'm gonna pause right there. So it's kind of a new concept, or you can just say, no, I'm good. Okay. All right. So what that allows us to do now is now we can actually evaluate each of these individually, right? Because we can find sine of 45 by itself. We can find cosine of 30 by itself, cosine of 45, sine of 30 all by itself, because those are values we know, okay? So we just took this, we used the difference identity to separate it, okay? So I'm just gonna call on a few of y'all, y'all can just tell me what we get here. So let's do, Fabian, you can tell me what is sine of 45, okay? Jocelyn, if you could tell me what cosine of 30 is. Sophia, if you could tell me what cosine of 45 is. And then Shatambi, if you could tell me what sine of 30 is. Okay, so we'll start with sine of 45. So Fabian, we'll start with you. I think I said Fabian. Sine of 45, what is that one going to equal?
That's gonna equal 0.85.
Well, let's do it as a radical, actually.
Radical, okay.
Yeah, so like on the unit circle.
Okay. That's gonna equal square root of 2 over 2.
Okay, good, thank you. And then cosine of 30? I don't know who I asked that. I don't remember who I asked that for cosine of 30. I think it was Jocelyn. Okay, she messaged on the group square root of 3 over 2. And then cosine of 45.
Square root of 2 over 2.
Okay. And then sine of 30.
Half.
Okay, awesome. So what we have now is we have values that we can kind of multiply and subtract to get what sine of 15 is, because we split it up into values that we know. So when we multiply these two first, that's going to be the square root of 6 over 4. Square root of 2 times square root of 3 is square root of 6. 2 times 2 is 4. We're going to multiply these two. It's going to be, we have that minus sign we're bringing down. It's going to be square root of 2 over 4. And then we can subtract them. It is going to equal, the denominator stayed the same. We can't subtract this and this. We can't subtract radicals. You can only multiply them or divide them. So we can't subtract them if they don't have the same radical. So they're just going to go next to each other. So sine of 15 equals that. That would be how you could find it without a calculator. How you could express it as a radical in its most perfect form without rounding the decimal, okay? And so if we wanted to check that, square root of 6 minus, what was it? I lost it. I forgot what it was. Square root of 6 minus square root of 2 over 4. We can see that they are equivalent, okay? So that's how you could use a sum and difference identity to find a particular value. Any questions? No? All right. Let's try a couple more, and then we're going to talk about the other identity, okay? So cosine of 75. So now we're looking at cosine, okay? Again, this is an equal sign. So we're looking at these, not these. And I like to just write out kind of some of our values. And you can use any of them really, as long as they add or subtract to give you 75. So in this case, help me out. Either you can write on the chat or you can say it by unmuting yourself. What could we use to where we can add them to give us 75, or we can subtract them to give us 75 here? Okay.
45.
We could do 30 and 45.
Okay, so I got 30 and 45, and then Michael in the chat said 135 and 60, minus 60. So you can use either of those. You can do 45 plus 30, and then you could be using this identity, or you could do 135 minus 60. Wait, that would be 135. Yeah, 135 minus 60, and then you could use that identity. So either one is gonna work there. Okay, let's use the 45 and the 30 just because they're smaller numbers, but either one will work. Okay. So in that case, if we use that, we'll separate this. So cosine of 45 and 30, right? So we're using this identity here. So it'd be cosine of, this is alpha, right? And this is beta. So it'd be cosine of 45 times cosine of 30 minus sine of 45 and sine of 30. right? And then we just would be finding what those values are equal to, right? And then whatever they equal would help us to simplify. So let's do the first one, cosine of 45. Jair, could you help us out with that one? Cosine of 30. Sophia, could you help us out with that one? Sine of 45, Jimena, could you help us out with that one? And sine of 30, Carlo, could you help us out with that one? Let's start with cosine of 45.
Square root of 2 over 2.
All right, thank you. So that's being multiplied by, what's cosine of 30?
Square root of 3 over 2.
All right. Thank you. Minus sine of 45.
Square root of 2 over 2.
Awesome. And sine of 30.
1/2.
Awesome. Great. I like to hear y'all's voices. It's good to hear y'all's voices because I can't see y'all. It's been a while since we've been in class together. So I'll call on y'all more. Awesome. Thank you. So then we're going to multiply, right? So we multiply those. It's going to be the square root of 6 over 2. Or no. Over 4. We multiply these. It's going to be square root of 2 over 4. We subtract them. The denominator stays the same when we subtract. So it'd be square root of 6 minus the square root of 2. And that is what cosine of 75 equals. And that's how we would find out without the calculator, right? We could check it with the calculator. If we put cosine of 75 in the calculator and we put square root of 6 minus square root of 2 over 4 in the calculator, it would equal the same decimal. So it is possible using the unit circle to find more than just the values on the unit circle, what it is equal to. So beautiful. Any questions? You can send a message in the chat or you can unmute yourself. All right, let's look at this one here. And then this is the last one with sum and difference identities. I want you to look at this and think about what you would, beautiful, yes, beautiful, Fabian, thank you, beautiful. Look at this and see what you would, what you think you could do to solve this problem. So think about what you could do to solve this problem. If you have an idea, you can unmute yourself and share.
Because it follows one of the formulas, wouldn't it just be the alpha is 50 and the beta is 20? So wouldn't it fall under like the second cosine formula where it's cosine of alpha minus beta? So wouldn't it be cosine of 50 minus 20, which is 30? And we could find that.
What do y'all think? Y'all agree? Yes? Okay. Yes, that's very good. Because it's cosine times cosine. We have that here, cosine times cosine. Plus sine times sine. We have that here, sine and sine. And alpha and beta are the same across the board. So we can actually combine them and kind of go backwards and write it like that, right? And then this would just be cosine of 30, right? And then cosine of 30 is just square root of 3 over 2. A lot easier. Because we could, instead of, you would have cosine of 50 would be, you would have to do the whole long formula to find cosine of 50. Then cosine of 20, you would have to do the whole sum and difference again. And you would have to do that multiple times, but it's easier if you can see the pattern, just combine all of this using the difference identity there, and then you get cosine of 30, which is square root of 2 over 2. Okay? Or square root of 3 over 2, sorry. Beautiful. All right. So that is the sum and difference identities. That is the other trig identity you have. We're going to talk about the last identity here in a second, which is double angle identities. Okay, so this is again the beginning I said we're kind of working down these. We talked about reciprocal. We talked about Pythagorean identities. Right now, we talked about these. I told you it looks long, but it's not that complex. If you're curious where the formula comes from, that would take me a little bit longer to kind of explain. It is in the textbook if you want to refer to it. I think it's chapter 5 if you're curious about that, okay? Double angle identities. That's these. That's what we're going to talk about here in a minute, okay? So these, again, are on your formula sheet, so you don't have to memorize them. But we're specifically focused on these now. So that's when you have sine of 2 theta or cosine of 2 theta, cosine of 2 theta, cosine of 2 theta. They can be rewritten as these, okay? Or vice versa backwards, right? So let's kind of first talk about how that works and how these actually are related to each other. So the double angle identities and the sum and difference identities are related to each other, okay? And so we're gonna first kind of see how that works. So let's kind of prove that this is true, okay? So if it says sine of 2 theta, we can actually rewrite 2 theta as theta plus theta. Because theta plus theta is 2 theta. It's like saying x plus x is 2x, right? So sine of theta plus theta, right? Okay. Now, this then, we could use the sum identity for sine that we have up here. Okay. And alpha is going to be theta, and beta is going to be theta. Okay. And so if we do that, we can use this, and it's going to be sine of theta times cosine of theta plus cosine of theta times sine of theta, because we're saying alpha is theta and beta is theta. And what ends up happening here is you have sine of theta cosine of theta plus cosine of theta and sine of theta. And when you add those two, since they are the same, another way to write sine of theta cosine of theta plus sine of theta cosine of theta is that you have two of them, right? And so you could also say it's just 2 times sine of theta cosine of theta, 2 times that. And that's where that's coming from, okay? So that just kind of shows you how they're related and why that works, and how anytime you have sine of 2 theta, we can just rewrite it as 2 sine of theta cosine of theta, all right? Pretty cool. Any questions? All right. So let's look at this. It would be the same kind of concept for cosine of 2 theta. So if we wanted to prove this, we could split cosine of 2 theta into cosine of theta plus theta. And we're saying that alpha is theta, beta is theta. And so in this case, we would be using the sum identity of cosine, which is this one here, which states that it's going to be cosine of alpha, and alpha is theta, times cosine of beta, and beta is theta. That rhymes. Beta is theta. Minus sine of alpha, and alpha is theta. Sine of beta, beta is theta as well here, right? And then we can see here that we can rewrite cosine of theta times cosine of theta as cosine squared of theta, right? And we can rewrite sine of theta times sine of theta as sine squared of theta. And that's where we're getting that identity from, okay? And so these are just some identities that kind of come from the other identities. And so they're all kind of related in unique ways, okay? All right, this is just me kind of just showing you how they work and how they're connected. And then we'll get to applying them in a problem, okay? So this is the last two identities here. And so cosine of 2 theta, you can also write that as 1 minus 2 sine of theta, or 2 cosine of theta minus 1, okay? So how does that work? Similar concept. Cosine of 2 theta we can rewrite as cosine of theta plus theta, right? And then we can use the sum identity here. Rewrite it as cosine of theta times cosine of theta minus sine of theta times sine of theta. Okay. And then, so same starting. This is going to be cosine squared of theta minus sine squared of theta. Now, right here, we want this to look like this. To prove it, I want you to actually think about what you could do to make that true. I'm going to pause it and let you get a minute. So you can switch cosine squared of theta to 1 minus sine squared of theta, you said?
Yeah.
Very good. That is that other identity, and this is where you kind of have to be able to see the patterns, right? It's one of the first trig identities that we talked about. Very good, Carla. You got a virtual ticket. Right here. Sine squared of theta plus cosine squared of theta is equal to 1, right? And we can convert that. We can move cosine squared of theta over, and then we could say sine squared of theta equals 1 minus cosine squared of theta. Or we can move sine squared of theta over, and we could say cosine squared of theta equals 1 minus sine squared of theta. And that's what we're going to use to apply that here. Where were we? I lost where we were. Were we here? Over here. So we can say cosine squared of theta equals 1 minus sine squared of theta. And we bring this down. And then we have 2 of these. So when you subtract sine squared of theta minus sine squared of theta is 2 sine squared of theta. And that's 1 minus sine squared of theta. 2 sine squared of theta. Very good. So it's kind of like a puzzle. You just kind of connect the pieces there, right? Very good. So it's similar over here to the right. If you're trying to prove this, you would, so this first part is the same. This first part is the same. So we would just pick it up right here. Right. So I'm not going to do the first part of the steps because that parts are the same. But then in order to show that this is true, what will we do instead? Ideas? So to prove that 2 cosine squared of theta minus 1 is equal to this, what would we do instead of what we did on the first one? Just slight change there.
Wouldn't it be sine squared of theta is 1 minus cosine squared of theta?
Yeah, exactly. That's 1 minus cosine squared of theta. And we have to keep in mind that this minus out here. So, and then we bring that down. So if we distribute this -1, it's going to be -1 plus cosine squared of theta. Right? And then we could combine these two, which is going to give us 2 cosine squared of theta minus 1. And that is why that identity works. Okay? All right. Very good. So now we just want to do a problem and applying those, and that'll be the end for today. There's really a lot that you could do in trigonometry with identities. We're just scratching the surface. There's a whole class on trigonometry. But this will be the kind of the end of what we're doing with identities. If we have time towards the end of the semester, we're going to come back to identities talk about solving a little bit more, and just kind of do some more stuff with this. But this will be kind of the last lesson for now, and later on, if we have some time, we'll come back in and do more with this, because there really is a lot that we can do with identities. So, all right, this is last problem I want to look at. So this would be is to solve something. Okay, so it says solve sine of 2 theta minus sine of theta equals 0 on the interval 0 to 2 pi. So there's kind of a lot going on here. This would be kind of using the sum and difference identity, or the double angle identity, to kind of help us out in solving a problem. So what this is basically saying is only on the interval from 0 to 2 pi, so meaning only in the first rotation of the unit circle, like not multiple rotations, what angle measurement in radians from 0 to 2 pi could we plug in here for theta that would make the statement true? So for example, could you plug in pi over 4? And then when sine of 2 times pi over 4 minus sine of pi over 4 would equal 0? Or pi over 3? Or like what angles could you plug in there that would make the statement equal 0? Okay, but the angle has to be from 0 to 2 pi. And in order to kind of solve this, there's a lot going on, so it's kind of, you can't really just tell by plugging in. Like I can't just say, okay, I think it's going to be pi, because you would have to do 2 times that, and then you would have to do this, and then you would have to subtract them and make it equal 0. So it's a little bit harder to tell. What we can do, however, is we can use some of these identities to help us out to rewrite this in a way that we can solve it, okay? So what do we see here that we could possibly use an identity for? Give me some ideas. What could we use an identity for? What part of this?
Sine of 2 theta is equal to 2 sine of theta times cosine of theta.
Okay, very good. We can use sine of 2 theta. And that's right here, right? Sine of 2 theta is 2 sine of theta cosine of theta, one of the new identities we learned. We could also use this, but we don't want to use that, because then we're just going to have something really long. We're trying to simplify our workforce. So good, we're going to rewrite that as 2 sine of theta cosine of theta. That's me just rewriting this. Is an identity that we just talked about. I'm going to bring down that. Okay. Now we just added, it looks like we added it to make it bigger, but it's actually going to be helpful, because now what we can do is we can look at this and say, okay, we see that we have a sign in both of these, right? And so we can factor out a sign from both of those. So it'd be sine of theta. We're going to factor it out. If we factored out the sine of theta, what we'll be left with is 2 cosine of theta would be left there, minus, right here we're going to have what? If we factor out a sine of theta.
Is it 1?
Mm-hmm. 1. And that equals 0. So we factored out a sine of theta, right? Why does factoring out a sine of theta help us? This just kind of goes back to our kind of basic concept of factoring. Let's say you had x squared plus x equals 0, and you wanted to solve for x. So you wanted to figure out what number for x could you plug in to make it true. It would help us to factor out an x, because then we'll end up with x plus 1 equals 0, right? And then we know that you will have 2 answers, right? One of them would be right here when that equals 0. So this one over here would be when x equals -1, right? because if you plug -1 in for x, you'll get -1 plus 1. And if this whole thing is 0, 0 times whatever this is still going to be 0, so that would be true. Or your other answer would be right here, if this x equals 0. Because if this x equals 0, 0 times whatever is in here is still going to equal 0. So we're factoring it out, and that's going to help us to see what it is possible for our answers that will make it equal 0. And so that means same concept here. It is going to be where this on the outside, wherever sine of excuse me, sine of theta equals 0 would be one answer. And the other one would be wherever 2 cosine of theta minus 1 is equal to 0. And we're going to solve those separately, and those will tell us what angle measurements that when we plug that angle measurement in here, it will make this whole thing equal 0. And if that whole thing equals 0, whenever you multiply times whatever is in there, it will still equal 0. Or if you solve this one for the angle, whatever you plug in here, you're finding what will make this whole thing equal 0. And if that whole thing equals 0 times whatever that is, it's still going to equal 0. Okay? Let me pause there and see if I got any questions, because it's kind of a little bit new, that what we're talking about right here. Did I lose anybody anywhere? Any questions? Okay. So now we got to think about it this way. What angle from 0 to 2 pi, so we can think about the unit circle, where on the unit circle is sine of the particular angle equal to 0? Or another way to think about it, sine on the unit circle is x or y. Sine on the unit circle is y, right? And so where on the unit circle is y equal to 0? Okay, so y is equal to 0 in 3 places, right? Help me out. Tell me some of the places. Okay, so I see on the message you're saying 0, yes, right here. So if the angle is 0,
180.
180, because here it's 1 comma 0, here it's -1 comma 0, right? And sine is y. What else? 360, yes, is the other place, right? 360 is just coming back around. So that means that this angle is equal to 0, pi, or 2 pi. If you plug in 0 or for right here, or if you plug in pi, or if you plug in 2 pi, it will equal 0. And if you plug that in here, like let's say, to make sure conceptually we understand what I'm saying, let's say we plug pi in here and here. If you plug pi in here, this whole thing would equal 0. And if that whole thing equals 0, whatever that equals, it doesn't matter, because 0 times anything is just 0. And if we take it all the way back, that means if we plug in pi here and here, since we just did some algebra there, if you plug in pi here and here, the whole thing is going to be equal to 0 when you subtract this minus this, right? Factoring just allowed us to help us to see that. Okay? So that will work for 0, pi, and 2 pi. Okay, good. So now let's solve the one on the right. This one we have to do some algebra. So you'd have to add 1. We would get 2 cosine of theta equals 1. Then we would divide by 2. So we have cosine of theta equals 1/2. So now we need to think about what angle measurements does cosine of theta equal to 1/2, and we're going back to the unit circle for that. So cosine of theta equaling 1/2, that would mean x has to equal 1/2, right?
60.
Okay, 60 degrees is 1/2 common square root of 3/2. Yeah, that is cosine is x. That's 1/2. So give me that in radians.
Pi over 3.
Okay. What other values is cosine of that angle equal to 1/2?
300.
Say that one more time.
300.
300. So let's take it. 300 is over here. The first hash mark. That's, yep, 1/2 common square root of 3/2. So what would that be in radians?
5 pi over 3.
5 pi over 3. Very good. Did we miss any? Yeah, I think that's everything, right? Because it's only going to be on the right side, because here is where cosine x is positive. Over here, x is negative. And we're talking about cosine. Very good. So therefore, to solve the original question in solving this, the answers would be theta equals 0, pi over 3, pi, 5 pi over 3, and 2 pi. Those are all the values that if you plug it in for theta, it would equal 0. And that is how you could use the identity in the context of a problem in solving for a particular angle. All right, so that is the sum and difference identity, and that is the double angle identities lesson. Hopefully you enjoyed the identities. I like trig identities because it's kind of fun. It's just a lot of algebra. Next class tomorrow, we'll talk about vectors, which will be a new unit. So there is a practice posted on Google Classroom on this. I think it's just 8 questions. All practices are due Friday, but if you'd like to get a head start, you can get a head start on that. Tomorrow we'll do a lesson, and then Thursday will be kind of a flex day, free day, break day, work on your other classes day. Any questions before we log out?